Hello and welcome to the Chapter 5 podcast on Section 5.3. Today we're going to be discussing the concept of enthalpy. Enthalpy is basically mechanical work associated with volume changes. Okay, because usually during chemical reactions, gas is occasionally given off, and as a result, if gas expands, it causes a shift in the volume to happen. So there's something known as pressure volume work, and this is work involved with expansion or compression of a gas. And again, depending on whether gas is being consumed or being created, this can affect the system. It is a function that accounts for heat flow. So it changes in internal energy as well as work that is associated with gas creation or consumption. And enthalpy is also a state function. So remember, with state functions, it doesn't matter whether you cooled to get there or warmed to get there. The current system is what it is. Enthalpy. What we have here are a bunch of derivations of enthalpy. So change in enthalpy is equal to the change in internal energy plus the work, which is the pressure times the change in volume. Change in enthalpy equals the heat gained or lost at constant pressure. So, if we have our change in internal energy, remember it's equal to Q plus W, and we said earlier on the previous slide that P is W is negative P times delta V. We can substitute these values in for E and P delta V, and notice how the work at constant pressure cancels out. So the internal energy, or the heat, is going to be equal to the enthalpy at constant pressure. So this derivation is just an elaboration of that. So in a lot of chemistry textbooks, especially lower level ones, they'll use Q and delta H more or less interchangeably, and the reason why that's allowed is because of the work being so small or canceling out in most cases. The differences between the change in internal energy and delta H are small, so whatever delta E is usually what delta H will be, and so on. Here's a little graphic over here that kind of defines heat flow into the system. The enthalpy increases because we're adding heat to the system, and when heat is leaving the system, the delta H will be less than 0 or negative. So one of those other things to help us associate sign convention with heat flow, so that way we're always assured of what direction heat is going and what signs mathematically will be associated with it. And that's it.